Hello students, today we are going to learn about reactions of metals and non-metals with water. In our previous session, we have learned that reactions of metals and non-metals with oxygen. So tell me what will happen when metals react with oxygen? Yes, they will form metal oxide. And same like metals, non-metals also form non-metal oxides. Okay? So, in this session, we have to study reactions of metals and non-metals with water. Okay? So, metal and non-metal. So, in case of non-metal, it is very simple that non-metals generally do not show any reactivity towards water. Okay, so in case of non-metal, they do not show any reactivity towards water. But in case of metal, metal shows different reactivity pattern towards water. Okay, for example, some metals are low reactive towards water and some metals are highly reactive towards water. Okay, I am just repeating. Some metals are low reactive towards water and some metals are highly reactive towards water. Okay, so for example, copper, gold, silver. Okay, so these all are metals. Yes, these all are metals. So these three metals, they show less reactivity or low reactivity. Here, less reactivity towards water. Okay, so think what will happen if I place copper, gold and silver in a water. Yeah, they show less reactivity. Okay, that's why we can easily put gold and silver into a water. But what will happen in case of sodium and potassium? That we have to discuss. Okay, so sodium and potassium, these two metals are highly reactive towards water. Okay, so here we have to take example of sodium over here. Just write down these things in your notebook. Okay, so metal, there will be, we can differentiate metal on the basis of their reactive pattern towards the water. Some metals are less reactive and some metals are highly reactive. For example, copper, gold and silver, they are less reactive, but sodium and potassium, they are highly reactive. And non-metals, they generally do not show any reactivity towards water. Getting? Okay. So, metals, when they will react with water, we have to complete this chemical equation. For example, if we take example of sodium, okay, so sodium. This sodium, when reacts with water, sodium is a metal. When they will react with water, metal form metal oxide or hydroxide. Okay, so here I am just writing hydroxide. Metal, when reacts with water, they will form metal hydroxide. Plus, there is a liberation of what? Hydrogen gas. And by this some metals also produce heat. Okay, in case of sodium. Okay, so in case of sodium, when this sodium reacts with water, this sodium forms sodium hydroxide. It is sodium, they will form sodium hydroxide. So to balance this equation, we have to take 2 molecules of sodium, 2 molecules of water. Okay, 2 molecules means 2 same atom. So 2 Na. Okay, 2 molecules of sodium plus water. This sodium will form sodium hydroxide. Okay, so check out how much sodium we have used here. 2 sodium. So 2 here, 1 reaction is balanced, not yet. So we have to use here 2. Now 2 sodium, 2 sodium. Okay, 2 oxygen. Yes, it is 2 oxygen. How many hydrogen? 4 hydrogen. And how many here? Only 2. So H2. Now check whether reaction is balanced or not. So 2 sodium, 2 sodium, here 2 hydrogen, here 2 hydrogen. Okay, 2 oxygen, 2 oxygen, and again 2 hydrogen. 2 hydrogen means total 4 hydrogen. Okay, so 4 hydrogens are there, yes. But hydrogen is evolved in the form of gas. So when the molecule is in the gas format, we have to show here upward arrow. Means there will be liberation of gas over there. Okay, and when this sodium reacts with water, they will form hydrogen gas, sodium hydroxide, and when we touch the beaker, it will give us heat or hotness. So sodium, when reacts with water, it will produce heat. Means sodium vigorously reacts with water. Just like we have already studied in our physical property topic that sodium is soft metal. Most of the metals are hard to touch, but sodium is the metal that is soft one. We can cut sodium with a knife. So unlike other metals, sodium is soft in touch. Okay, so this sodium is highly reactive with water. Okay, and it is highly reactive with air also. If we expose sodium in a air or in a water, so it will catch fire easily. So to store this sodium, we have to use a kerosene. Okay, in case of phosphorus, phosphorus is a non-metal, and just we already studied that non-metals do not show a reactivity towards water. But this phosphorus is highly reactive with the air. Okay, so if we expose this phosphorus in the air, it catch fire easily. To store this phosphorus, we have to use kerosene. Okay, so for here they have given you one activity, that is activity 4.5. Okay, and for this activity I am going to send you one link on your WhatsApp group. Please watch that link, and after watching that you have to write observation and result about that activity into your notebook. Okay, just one more thing I have to tell you that here I am going to take another example, that is iron. Okay, so iron is a metal. Then what will happen about this metal? So if we expose this iron, or if we put inside iron into a water, this iron reacts with water, and this iron and that we call as corrosion. Okay. So this iron when reacts with water or moisture or atmospheric oxygen, they will form compound on it. So it is called as corrosion. So it is also one reactivity pattern of this iron with the water, that they form a corrosion. Okay. So it is about the metal which reacts with water. So just I am repeating, metals, all metals do not show the same reactivity pattern towards water. Some are highly reactive, some are less reactive. Okay. So non-metals do not show any reactivity towards water. Yes. Okay. So just revise this session. I hope you all understood this topic, that reaction of metals and non-metals with water. Okay. And one homework for you, you have to watch that link and write down observation and result into your notebook. Up to this, thank you and stay home, stay healthy.